Bismillahirrahmanirrahim. We have three major components. One is R, the other one is C, and the third one is inductor called as L. So if we take two combinations such as RC or RL, so these type of circuits will be solved by first order differential equations. So what type of circuits we will form with these type of components? So there will be one resistor and one capacitor. So there will be one inductor and one resistor. So these will be the circuits. So if no source is connected in the circuit in that type, we see that the response of the circuit will be called as natural response. You can see that in both of the diagrams there is no source connected. So we will solve our first circuit, and that will be our RC circuit. So let's again draw that diagram. So we have a capacitor and a resistor is connected to it, and this one is C. We see that there will be two currents. One will be called as IC, the other one will be called as IR. We say this is our node voltage, and that is a function of time, and this one is our ground. And the initial voltage of the capacitor, we will say V naught. That will be our initial voltage. We also say that this will be V0, or this is the voltage of VT. So initially our capacitor is charged at V naught. We don't know the value of V naught. So let's solve this circuit. So we have, applying the node analysis, we can solve by IC plus IR is equals to 0. So we have the equation of IC, and you already know that is C dV by dt plus V over R is equals to 0. So what we do, we divide the whole equation by C. So we'll get dV by dt plus V over RC is equals to 0. Now dV by dt is equals to minus V over RC. Now what we do, we take voltage on one side and dt on the other side. So we have dV divided by 1 by V is equals to minus 1 over RC times dt. Now we take the integration on both sides. So we take the integration. So this will become 1 over V, which integration is natural log of V is equals to minus 1 over RC times t plus, this is the constant of integral. Now we see that natural log of V minus k is equals to minus 1 over RC times t. We can write also k as natural log of k. So we have natural log of V minus natural log of k is equals to minus 1 over RC times t. So this becomes natural log of V over k is equals to minus 1 over RC times t. We take the exponential on both sides. So we have e raised power natural log of V over k is equals to e raised power minus t over RC. Now we take here. So e will be cancelled out by natural log. We get V over k is equals to e raised power minus t over RC. Now in next step, we want to evaluate what is the value of k. So we have V is equals to k e raised power minus t over RC. Now for that case, we have to take the initial values that we have already taken, that when time t is equals to 0, time is equals to 0, what was the value of V naught, that the voltage across capacitor, that was equals to V naught. So time t is equals to 0, k e raised power minus 0 over RC. So this factor will becomes 1. So k will becomes equals to V at time t is equals to 0, and this will be equals to V naught. So our equation will become V at any time, that will be equals to V naught e raised power minus t over RC. And of course this will be in volts. So this is the solution of our first order differential equation. So let's plot this curve, and we get, on x-axis we have time, on y-axis we have the value of voltage, and at the maximum value its voltage will be V naught. As we know that when we place t is equals to 0 here, t is equals to 0, this exponential will become equals to 1, and Vt will be equals to V naught. So if we plot this type of curve, so we get a curve like this one. It will never touch the x-axis line because at time t is equals to infinity. Infinity is just a value. Then it will touch the horizontal line. But we define that at this will be our value when RC is equals to, when t over RC, that will be equals to 1. So we will say that this will be our tau is equals to 1 time constant. This will be our value at 2. This will be our 3, and this will be 4, and this will be 5. 5 is the value where we see that e raised to power minus 5 over RC, t over RC, when it is equals to 5, so it will be less than 1%. So we consider that our capacitor is totally discharged at time constant 1 t over RC. Let's make another equation. V naught e raised to power minus t over tau. This tau is called as time constant, and for RC circuit this is equals to RC. So this plot, and in future examples we will solve that numericals, and we will understand in more details that what is going to happen in this numerical.